Hello, I'm Sarah Hardy, and this is a video for my Mat 120 Introductory Statistics class, and this is a video on the measures of the center. So first, some announcements. Before watching this video, you should watch the video on histograms. I noticed I forgot to put announcements in that video. And then a webassign covering both videos will be due on Monday, September 14. Okay, so enjoy the video. So we're going to start by looking at numerical summaries for one numeric variable. And so if we have a list of values for the numeric variable that we would like to summarize in some way so we could convey them to others and put it in a report. And those two features are the center and the dispersion, which is a fancy word for how spread out the values are. So let's first talk about the center. And there's really more than one way about thinking of what's the center of a distribution of numbers. One way would be to think about, like, where does that distribution balance? And the mean is the balancing point of a distribution. Or another way to think about the center would be, well, if half the values are on one side of a point and half the values are on the other side, then that's the center. And the median is actually the point where half the values fall above and half the values fall below. So we have two ways to describe the center of a list of numbers: the mean and the median. So how can the center be two different things? So let's look at these histograms, these three histograms below, and look at how the point where half of the values are on one side and half are on the other side, and how does that compare to the balancing point? On this first graph, I think we can visualize that it's going to balance right here, and that is also the point where half the values are on that side and half the values are on this side. So this point is the mean and the median. So in this case, these two measures of the center, the mean and the median, equal each other. But what about this second graph? And it's the same number of observations, but I've taken this last group and moved it over. So the median is in the same place. We still have half the observations on this side and half the observations on this side, but if you tried to balance it, would it balance at this point? Now, if you try to balance it right here, it would tip this direction. So to balance it, you'd have to move your fulcrum over here somewhere. So the mean is maybe around here, and it is less than the median, which was in the same place. And this last graph is the same situation. Median in the same place, but now to balance it, you're going to have to go a little bit in this direction, otherwise it's going to tip down this way. So maybe the mean is about right there. So these are ultra simple examples of some basic shapes we tend to see in histograms. Something like this, which is symmetric around the middle. In a perfectly symmetric distribution like this one, the mean equals the median. But when we're dealing with real data, the mean is approximately equal to the median. They may not be identically equal. So everyone has seen means and medians in high school. So we're going to just go through the calculations here rather quickly. So let's look at the small example, and let's imagine there's a small company, and we're looking at the record of the number of days the employees were absent over the last year. So let's first imagine that there were 9 employees, and these are the days absent, and we want to find the mean and the median. So first of all, to find the mean, we're going to start by adding them all up. So start by adding up the numbers to get the total, and then divide by 9 because that is our number of observations. So when we take 29 divided by 9, we get 3.22, and that is our mean, and that is the balancing point of the distribution. To find the median, we're going to first arrange the numbers in order. That is a very important step. The median will actually be a number in the distribution, and note in this example 3 is this number from the distribution, and then when they're arranged in order, there are 4 observations below that 3 and 4 observations that are greater than that 3. So our median is 3, and note that this is 3 is fairly close to 3.22, which was the mean. So to look at what we do if there's an even number of observations, let's imagine there was instead 10 employees, and that 10th employee was absent 2 times. And so now if we arrange them in order, we have this. Our new total is now 31. So the mean is 31 divided by 10 because that's the number of observations now. And so the new mean is 3.1. And now we really have 2 numbers here that are in the middle. So notice like we have 5 observations here, 5 observations here. So this is the middle, and it comes between the 2 and 3. So what we're going to do to find the median, in this case, instead of using one of the numbers from the distribution, we're going to average these 2 numbers. So our median is now 2 plus 3 divided by 2. So 5 divided by 2 is 2.5. And the mean of 3.1 and median of 2.5, those are a little farther apart than before, but they're still fairly close. Now, suppose instead that last 10th employee, instead of being absent 7 times, was absent 70 times. Suppose they got in a bad accident, and Bob, he was in traction for 3 months, and he's fine now, but yeah, he missed a total of 70 days. So now when we add the numbers up, our total grows enormously. Our new total is 94. So when we take that new total, 94 divided by 10, we get a mean of 9.4. But the median, when we have them arranged in order, it doesn't matter if this is a 7 or a 70. We still have 2.3, or 2 and 3, I should say, in the middle, and our median is still 2.5. Now the mean, 9.4, and the median are very different. It's like 2.5 times as big. So the mean is much larger, or much greater than the median. So a number like this 70 that's unusually large or possibly unusually small, those numbers are called outliers. And we can see here how the median is not affected by an unusually large or unusually small value on one side or the other. However, the mean is very affected by unusual observations because the mean gets pulled in the direction of the unusual observation. So if we want to look at the two graphs, this is the graph when the 10th person was absent 7 days compared to how the graph looks when that person is absent 70 days. So the mean, to balance it, we have to move that balancing point out towards that direction. So statisticians say that the median is robust or resistant to the effect of outliers because it's not affected by outliers. The number doesn't change. So in this next example, let's imagine that these were bonuses paid at company Z at the end of the year. So in this distribution, will the mean be greater than or less than the median? So what do you think? This example, like our last one, has some unusual observations on the high side here. So that's going to pull the mean towards that unusual observation. This is an example of a skewed distribution where the mean is greater than the median. Now, here's a thought question. Suppose you were a journalist and you were writing up an article about this company. Would you want to report the mean or the median? Which would be better? And what does better actually mean? If you were instead applying for an entry-level position, you would probably be more interested in the median because that would be closer to what you would probably expect in an entry-level position. Someone reporting for the CEO position would be more interested in the mean because that would be closer to what they would expect and give you more information about like the overall company and how much they're paying out in total. And if you were a journalist, I would actually advocate for reporting them both. There's not one that's necessarily better than the other one. It all depends on the context. And just the fact that if they're different, that is in itself valuable information to have. Or if they're the same, that's also valuable information. So I would say report both. You don't have to choose one or the other. So suppose you have a population with two groups. We'll call them A and B. And in this population, 60% are in group A and 40% are in group B. Well, if you were going to report a mean of some characteristic, you might want to know, is that different for group A and group B? So you might want to report those separately. Well, if you did that, how would you then find out what the overall mean was? And to find the overall mean, what we would do is something called a weighted mean. So let's suppose the mean for group A is 7.4 and the mean for group B is 12.6. And we want to find the overall mean. We can't just average these two numbers because we have more people in group A than group B. So we're going to weight these numbers by the percentages. So to start, we have to remember that when we do calculations, we're going to use the decimal form of a percentage. So to find the weighted mean, we're going to take mean for group A and multiply that by the percentage in group A, which is also called the weight. And we'll take the mean for group B, 12.6, and multiply it times the percentage that are in group B, and then add those two together. So if you punch those numbers in your calculator, you should end up with 9.48. And notice that this number is closer to group A's mean than group B, and that's because there's a larger percentage of the people in group A than in group B. So suppose instead we had 80% in group A and only 20% in group B. In that case, your weighted mean would be 7.4 times 0.8 plus 12.6 times 0.2. And if you punch that in your calculator, you should get 8.44. So notice now that this is even closer to the mean for group A because we have a higher percentage in group A than before. Now suppose instead you had 3 groups and the mean for group A was 52.3, mean for group B was 35.8, and the mean for group C was 14.1. And 15% were in group A, 65% in group B, and 20% in group C. Now to find the weighted mean, we just do the same thing, but we do it for 3 groups. And just a final note on this, a little reality check here. The answer must be between the smallest value, which was 35.8, and the largest value, which was 52.3. So for example, like when I just entered this in my calculator, I entered something wrong and I got an answer of 70 something. So I knew I had made a mistake and I had to go back and look at it because 70 was larger than the largest value. So this is just a little reality check to see if you're in the right range. So at this point, this is the end of this video, and you should do the web assign on histograms, means, and medians.